So we have the third problem from the practicing with velocity and conversion worksheet. This one is an actual speed versus speed equals distance over time problem. So you're given the following information. Something has to go 20 feet and the speed at which it travels is 40 centimeters per second. So this is the information initially given. So we are told that our speed is 40 centimeters per second, and the distance is 20 feet. So in a straightforward, perfect world, I would just go directly to this equation. I would say speed equals distance divided by time. And I'd love to just plug in speed and distance and solve for time. In order to do that, I would actually have to solve this equation for time. So to do that, I need to bring time to the top. Let me move this down, give us a little more space. So I would multiply this side by time and this side by time. What that would give me is time times speed equals distance. And then to get time by itself, I now divide both sides by speed. And this is going to leave me with my final equation that I'd like to use that says time equals distance over speed. Now, if the problem were easier, I could just plug in at this point. However, I have an issue. The units do not agree. I have two different length units here. I have centimeters and feet. I need them to agree. It does not matter which way I convert. I could convert centimeters to feet, or I could convert feet to centimeters. I prefer to convert feet to centimeters because it doesn't involve a two-part unit of centimeters per second. So I'm going to approach this problem by, before I use my equation, converting 20 feet to centimeters. This is going to require two steps because I'm going to have to go from feet to inches and then inches to centimeters. So, set up 20 feet, need one conversion factor, need a second conversion factor, all in hopes of getting to the end of centimeters. Feet is in the numerator, so I need to put feet in the denominator, so it will cancel out. Inches up top. I know 1 foot is 12 inches. I'd like to get rid of inches, so I have to put it opposite to the other inches. So inches in the numerator requires inches in the denominator. And I want centimeters up top. 1 inch is 2.54 centimeters. Again, all of these conversion factors can be found in the first worksheet we gave you. What this does is give me 20 times 12 times 2.54 all over 1 times 1 times 1. If I go back, I can cancel out just to double check that I got everything. Centimeters is my remaining unit, which is what I want. So 20 times 12 times 2.54 is 609.6 centimeters. So I now have units that match. I can go up here and write that this equals 600, I'll just make it 610. I'm going to round to make life a little easier. Don't worry about rounding, the rules of it. You will learn much about that when you get to chemistry. So I'm going to come over to the original equation that I have. Actually, let's just take this down. we'll copy this, come down here, paste. And I know that the distance is 610 centimeters. The speed is, what did we say? 40 centimeters per second. So every 40 centimeters I move takes 1 second, and I have to travel 610. So I will divide 610, divide by 40, and get 15 1/4, 15.25. Now the units are kind of funny here. It's centimeters over centimeters per second. That unit reduces to seconds. I'll show you how I do that. This really looks like centimeters over centimeters per second, which is really centimeters divided by centimeters per second. And if I put this over 1, you can see that as dividing fractions, which is centimeters times seconds over centimeters. Centimeters cancel and I get seconds left. However, we're not done, because this last problem asks me to get this answer in minutes. Right? If you go back to the original problem, you'll notice it says how many minutes. And my answer is in seconds. So I need to do one last conversion. I need to convert this problem 15.25 seconds times seconds in the denominator, 60 of them in 1 minute. This is one of the more straightforward calculations you know how to do. It's going to be about 1/4 of a minute, or 0.254. Oops. See if I can squeeze in minutes here. There you have it.